Hi there. This is an introduction video to assignment 2, String Me Along in CS 107. If you can't tell from the title, this assignment is all about strings, in particular C strings, and it deals with manipulating C strings, using C string libraries, being able to use pointers as they're associated with strings, and being able to walk through strings and manipulate them and so forth. So by the end of this assignment, you will be very good at C strings. The assignment itself has a number of parts. The culminating part of the assignment is to write a program which mimics, to some extent, ours is actually a little bit more advanced, than it mimics a program that is in Unix already, and I will show you how that works as we get to it. So let's begin here, and obviously you need to clone the assignment that as you normally do, and I'm going to show you something else as well as we go along with this cloning. There have been a couple students who have made changes to their code, to the original starter code, and then wanted to go back and look at the starter code, and they didn't know how to do that. And it turns out that it's a little more tricky than just finding it on our repository somewhere. So I'm going to show you how to do that, and it's fairly straightforward, but you might as well know how to do that now. So anyway, I'm on Myth now, and I'm going to go into my my 107 folder, and I'm going to clone the assignment. And just like the other assignments in assignment 2, there's some starter code. Code.c is kind of a testing one where you can write some tests and do some checking. And then mywhich.c is the program that you're actually going to write. And then scanToken.c is another function you're going to write in this file as well. As with the other assignments as well, we have a samples folder where you can actually see the various solutions that we have. You can run the various solutions that we've made for you, and you should always check your solutions against the output of our solutions when you're writing your code. One thing that people do, I sometimes see people say if they want to test the solution, they go cd samples and then run the solution. Guess what? You don't actually need to do that. You don't have to be in a particular directory to run a program. You can actually type samples/mywhich solution and run the program straight from the command from the folder that you're already in. So some people might want to do that. Now, if you do want to go back and look at the original starter code, there is a guest repository which you can actually clone. Instead of saying $user, if you say or if you say just guest, like this, guest, and then let's say we put it into assign2 guest, right? Don't put it into just assign2, it will overwrite your code. But we'll just put it into assign2 guest, it will actually clone there. And then if you cd into assign2 guest, then the originals will be there as well. Okay, so you can look at the original code and you can see what the code was. So that's available to you if you want to do that. Okay, I will go back into my regular assign2 and go back to the assignment itself. All right, so the first thing you have to look at is a code study, which is the atoi command, which we have used before in assignment 0. We used atoi, and it stands for ASCII to integer. In other words, it will take a string and try to convert it into an integer. This is not always successful. If it's not successful, it generally just gives you back a 0 value. In fact, you're going to test some of those and report on the results of those. So you have to read through some of this code, and the code is much like a lot of code in the wild, a little bit dense. Okay, there's some string functions in here. There's some pointer arithmetic in here that you may need to take a look at, like s++, for instance. That's a sorry, is space is not a string function. It's just a function that will look at a particular character. And then you have to look at some interesting pointer arithmetic that will change the value of the pointer, in this case incrementing it, as you go along. In this code in particular is also a switch statement in here. One of the questions asks about this. If you're having trouble understanding what's going on here, I know in 106B we didn't really cover switch statements too much. We might have just briefly mentioned them. But if you want, look up switch statements and make sure that you look at the specification completely, because it is a little bit tricky what's going on in the code right here. So I will put a link, in fact maybe I'll overlay the link that you should look at in the code right on this video. The next thing you should do is obviously answer the questions in the README for the atoi function. The questions are relatively straightforward, but as with anything else, they take a little time to process, and you need to actually dig in and figure out how that works. The second code reading is on the string function called strtok, which is about tokenizing a string. In other words, taking a string and it may be separated by some token, like a comma or a period or a colon or something like that, and breaking it up into pieces that are divided by those delimiters. In other words, that colon or that comma, etc. And it is a function that is not particularly well specified, not particularly, let's put it this way, it's an ugly function. You're going to look at it in a second and see why when you actually take a look at it. But strtok is a function that it doesn't do nice things like your string split function from CS106B. It doesn't take your string and then give you back this nice array or vector of all the different parts of your string. It does things one token at a time, and it makes you call the function on the string multiple times in a very peculiar way. So I'm not going to go into more details here, except to say that when you read through this, first obviously read the rest of the comments here as far as the what's going on. But what you want to understand is this is not really the kind of function that you'd normally write these days. It's a function that is not particularly, it's hard to explain exactly why it's not great until you see it. But it has things like a static variable in there, which you probably haven't seen before. It actually modifies your string that you passed it in that you want to tokenize, so it actually changes it on you. And so not particularly good behavior. Now, why are we making you read this arguably terrible function? Well, part of it is to see what it does, and part of it is to, once you see what it does, write a better function that does very similar sort of, has similar behavior, but is in a much cleaner way. So we've come up with another function that does the same sort of thing as strtok, but it actually does it in a much cleaner fashion and is the kind of code that you may strive to write. So answer these questions about this. You may have to look up some things about static variables, as I kind of briefly mentioned before. And once you get through reading this function and saying, wow, that's kind of a horrible function, you're going to go to part 3, which is to write scan token, which is more or less the same idea, but in a much cleaner way. Now, scan token does the same sort of thing. You call this function on a string multiple times, and it returns to you the next token. Now, what it does is it actually keeps track of, or it gives you back a Boolean whether or not it succeeded or not, whereas strtok actually gives you back a pointer to where in your string the next token is, and also modifies it. And then this uses a buffer that you pass into it. In fact, you also have to pass the length of the buffer, and it places the next token into that buffer for you. Okay, and there's some caveats in there about how this works and some specification details that you have to look up. But it also updates a pointer to a pointer that you give it about where the next token ostensibly begins, or actually where the first token, after where the first token ends. And so you have to read into more details about what this is actually doing. But know that what you're writing here is not only to replace the strtok function, which we said is not too great, all things considered, and then you want to also you're going to actually use scan token in the final program. So write it well and test it well, because it will be used in your final program. Okay, the final kind of code study that we're doing is not really that intense. It's basically saying, hey, how do we read what files are in a particular directory? And the way we do that is we use the header file dirent.h, and that defines some structures for us and some types for us that we will use to hold that directory information. Okay, so here's a very quick example of how it works, and really the idea of showing you this code is saying, hey, you're going to use something similar to this in your final program, so you might as well figure out how it works by seeing a good example about this. What it does is it actually opens up a directory and then checks to make sure that it successfully opened it up, and then it goes through all the directory entries by calling this readdir function on the path, and then it actually, or on the directory object or directory variable that you give it, and then it prints out the names of the directory. And then it also calls a closed directory there. So really what we wanted you to do is see how this works, dig into the spec on what this dir type is, and see how it actually works in here, and then also like what this struct dirent is as well. So where are you going to actually find these things out? Well, you're going to go and you're going to look up dirent, and you're going to look up readdir in the manual page, and you're going to do like that, and you're going to look it up, and you're going to find out that, oh look, there's a struct definition for us that you're going to have to answer some questions about, and there's some other things that you may want to do. So it's not a very long man page, but important to read through that to see what's actually happening when I say readdir, when I call that function. So anyway, so that's all setting you up, reading all that code and writing this scan token function to actually set you up for the final part of the assignment, which is implementing this mywhich program. Before I mention that, don't forget, just like in assignment 1, we do want you to review and comment our starter code, the parts that we wrote for you. Okay, we want you to be able to do this so that A, you understand what the program's actually doing, the starter code's actually doing in main and so forth, and then we want you to be able to, describe to us in comment form, get practice commenting the code as well. All right, now the final part of this assignment is a program called mywhich. So what is this program? Well, if you go into the Linux terminal and you type which and then some command like ls, which ls says, oh, the ls that I'm going to use when I run the ls command lives in /bin/ls. So we look at that, or /bin folder. If you look in bin, there's a whole bunch of programs in there. Bin stands for binary, by the way. All of these programs live in /bin, and they are the programs that you use all the time. So grep is in there, for instance, and let's find some other ones in here that you may be using. CP for copying, cat, we've seen that, and so forth. So a lot of the programs that you use quite often are in the /bin directory. And so this just tells you where, when you say which ls, it will say, oh, I'm going to look in /bin/ls. Well, how does it know where to look? It doesn't look at the entire directory structure, right? It looks in a place called your path. Now, if you look at the path variable, now this is a bash way of doing things. There are these things called environment variables, which you will learn about in the lab this week. And one of your environment variables is your path. And your path, if you look at it, my path has all of this stuff in it. In fact, some of this is extra, more than what yours may have in it. But yours will probably have mostly up to about here in it. And what it does is it says these are the places where you are allowed to look for files to run. And the which command uses this, extracts the various parts of this. Notice, this is a string, which is a path. There is a colon here, and then the rest of your string, and then another path, and then another colon. This is a delimited string. And it's, guess what? Your scan token is going to be able to be used to parse this and to take out the various parts of your path. So that's how which actually works. Now, because we don't want you to mess around with your own path, we're going to have you work on either your own path, or we are going to be able to let you modify it to be able to test various things by passing in another variable called myPath, and that's going to be easier than updating your actual path. If you actually update your path, then things will break. For instance, if I said export, don't do this. If I said export path, and then if I said export path equals nothing, I'm trying to do this, let's see, equals just nothing, then, whoops, I did it wrong, forgot the no $sign. Export path equals nothing. Then if I do echo path, right, it will not, I have no path. If I try to do ls, it will say no ls because it doesn't know where to look anymore. So what you want to do is you don't want to be changing your path like I just did because that can get ugly when you try to do some tests and things. So I will change my path back and to there, and now I should be able to do ls. So you want to do that. So the mywhich program that you're going to write will use as a default the path, but it will also be able to use a modifiable myPath that will be able to that you'll be able to test and check and so forth. So that's how we're going to do that. You should first obviously figure out how which or what which does, play around with it a little bit, see how it works before you go and write the program. But the program itself you are going to write is going to, like I said, use this myPath variable, and it's going to use path by default, but you can change it to be the myPath variable, and it will do some different behavior. If you just type which by itself, it doesn't do anything. But your mywhich should say directories in search path, and it should list all these directories. This is basically using your scan token function to do that. Okay. Then if you give it a variable or an actual parameter, it will look for that parameter in your path or myPath variables or environment variables, and it will determine whether or not those are executable. And the assignment here talks a little bit more about how to determine if a path is executable. I believe it's actually in the device FAQ page, how to do that. So you should read that. But the point is that it should determine whether a file is executable and then print it out to the screen. Okay, so that's how that works. Okay, it's also going to have an added bonus function, which is if you put a plus before your file that you're trying to see where, like an executable file that you're trying to determine where it lives, it will use that as a wildcard, which means that it's going to actually tell you all the paths that match any part of that string, or any programs that match any part of that string, which is kind of neat. It's actually, I think, a nice little addition to the which command. The standard which command does not do that, as it turns out. So, what are some other things you need to know about this? You're going to call mywhich by saying mywhich and then the command. By the way, you can test our solution again. Sample/mywhich ls. I think it's mywhich solution ls, right? And it will tell you that that's where the solution lives, right? What if I said plus ls? Well, then it says here's where all these other things that have ls in them live. So, and would be executed, right? So it says, okay, well, there's a file in /user/sbin called alsactl, and guess what? It has ls as part of the wildcard in there, and all the others meet the same requirements. There's an lspci function in there, which is in user/user/bin, and of course our ls is also there. So the plus is going to be the wildcard in that case. Okay, if you don't do it with any arguments, it actually gives you all the different paths that are in your path in that path variable. And so it lists those out for you. And this is different behavior than the main which, the actual which program. Okay, so all that is how this actually works. And you should make sure that your program works with 0 arguments, with more arguments, and works with the wildcard. You can assume that it works correctly. You should always, again, test our solution if you want to find out if it's working correctly or not. And then you should be able to use the myPath variable that you would have learned about in lab this week, so you'll be able to figure that out if you go to when you go to lab. And then you aren't allowed to use functions that do the work for you, right? There's a function called an envp, so that you can see in sorry, you have to use the envp argument in main, but you're not allowed to use the getEnv function or the end function or which function, I mean, obviously, or which file or whatever. You're not allowed to use that. Obviously, you have to build it yourself. So as I said, go to the advice page if you want more information. For instance, this says, don't try to do something fancy where you're taking your path and then creating some vector or array of strings for you. It's not worth it, right? It's also slower. So what we want to do, and it takes more memory, so you want to do this one command at a time by calling your scan token function on the actual path every time you call the function, okay, or every time you're going through or as you're going through all the path variables, okay. It talks about how to assemble the path names, testing if a file is executable. You can use the function called access, which will give you the information you're looking for. Okay, so you have to figure out what the mode is, and it says how to do that in man access. And you should be able to test it. Again, you can look at the mywhich solution to figure it out. We haven't even learned about malloc or free yet in this class. You do not need to use malloc or free. In fact, you should not use malloc or free. If you already know what those are, great, don't use them. Don't need to, and you should not be using them in here. Okay, and there's a little bit more on const as well. So that's about it for the assignment. It's a good assignment. It is a fair amount of code to read, and it is also a fair bit of code, a small amount of code to read, and then a fair amount of code to write for your first real program in CS 107. As always, ask questions on Piazza or come to office hours, and good luck on the assignment. Thanks.